Hi there. Today we're going to talk about the area of composite figures. This is a review of several concepts that you probably have learned throughout 5th, 6th, 7th, and 8th grade. So hopefully these things all come together for you as you get ready to come into 9th grade here at University High School. First thing you want to do when we're looking at area composite figures is just remember quickly just what does an area mean. When we're talking about area, what are we talking about? Remember, generally we're talking about the amount of space inside a two-dimensional object. Okay, so how much space is inside of there. And we often, when we began probably back in 5th grade, we would use unit squares like these to then draw some pictures and say, all right, well, I have some unit squares here, and they'd all be equal to like 1 unit each, and have this shape that would look something like that. And we want to know how much of an area does that shape fill up. And you know, you could move things around and put it over there and put that one over there to end up with a nice full shape of something like this. And we would say this shape here has an area of 8 units. Each one of these squares would be considered a unit. And then when you put that together, we have 8 units here. 1, 2, 3, 4, 5, 6, 7, 8. And that's something that you did again back in 5th grade there. And you probably primarily played with squares and rectangles, when you did that. And you would be given a shape like so, and then maybe it would be divided into 2 parts there and 3 parts here. And we talk about this having a length of 3, or length or width of 3, and then the other side being 2. And we would say, well, what is the area of this shape? And we'd say, well, to find the area of a rectangle or square, the area would be solved by determining the length times the width. In this case here, the area would be like a 2 times a 3. And we would say we'd have 6. In this case here, if we called it inches, we might say we have 6 inches squared would be the area of a shape like that. And we would talk about length and width. We would also use things like talk about base times height. And either term is just fine, right? It's all going to be the same. So area can be base times height, area can be length times width, and perhaps you had at some point eventually, some shapes that maybe used different numbers. So we have maybe something like 5 inches here, and we have 3 inches here, and we'd say, well, to find the area of this shape, we would multiply the base times the height. So the area in this case would be equal to 5 inches times 3 inches. And when you multiply 5 and 3, we get 15, and an inch times an inch is inch squared. And so the area of this shape would be 15 inches squared. So again, this is something that you probably started to do back in 5th grade. Okay? So before we go further then, let's just kind of quick review. I want you to try one on your own real quick. So here's our first one you're going to try. So let's find the area of a rectangle with a base of 9 inches and a height of 3 inches. Okay, so why don't you go ahead and maybe push pause on my video, or if we're doing a little different program, maybe it's going to pause for you, and let's find out what the area of a rectangle is with a base of 9 inches and a base of 3 inches. You solve that real quick, and then I'll give you an answer here in just a second. Okay, so to solve this one, hopefully you recognize that we had a base, right? And so we had a base of 9, and we had a height of 3. And if you were to draw that out real quick and sketch it, we would draw something like 9, and say 3, and draw that rectangle shape out. Again, it doesn't have to be perfect here, but I could say this has a 9, and this is a 3. And when I multiply those together, I know that the area equals 9 inches times 3 inches. And so my area becomes 27 inches squared for that shape right there. Okay, excellent. All right, that's the first part. That was probably what you did in 5th grade. So moving on to 6th grade. In 6th grade, you started to then use the area formula you used, base times height, and apply that to what we call parallelograms. Now, a parallelogram is a lot like a rectangle in one sense. It has two sets of parallel lines, but it doesn't necessarily have the right angles, right? Like a rectangular square would have. We have two sets of parallel lines, one on the top and bottom, and then we have the ones on the sides. And they're parallel, meaning that they go the same direction and they would never cross. That's a parallelogram there. And when you talked about this in 6th grade, hopefully, one of the things they asked you to do was they might have asked you to decompose the parallelogram and turn the parallelogram into perhaps a rectangle. All right, and the way we did that back in 6th grade is you would take a parallelogram like this one here, okay, and you would say, I want to find out what its base and its height is. That's kind of what I'm thinking. I want to know what is the base and what is the height in order to find the area. That's what I'm looking for. And when I look here, I can see, well, I definitely have a base. That seems pretty straightforward here. But the height, I can't use this as a height. To use anything as a height, it needs to have a right angle or come down perpendicular to the base. It needs to be in a right angle like so. And this one just does not do that. But what we decided we could do is we could actually decompose this by doing this. We could pretend we could cut this right there, and we can actually take this pink triangle section right here, and if we took this pink triangle section and we cut it, we could actually cut it and then move it right over here. And in doing so, we end up with, and I'll make it in green here, we ended up with this, after we decompose it by breaking apart, when we assemble it back together, we end up with a rectangle. And at that point now, we do have a height that we can work with, right? So that becomes our height. So the distance from here to here is the same, and that is also the height. And when we were doing that, then we were able to say that if I knew the base and I knew a height here of the parallelogram, I could then use the same formula I used before to find the area of rectangle and square to find the area of a parallelogram, as long as that height was perpendicular to the base. And that was a key thing there. Okay, so let's do one real quick. I want you to go ahead and try this real quick, knowing that the height is the measurement inside the parallelogram. That's going to give you an area thing, okay? So let's do, well, before you try it real quick, let's back up there. Let me try one with you real quick. Sorry about that. So here's what we did. If we have a shape like this, and we go like so, and we said this has a base of 4, and we had a height here of 2, then the area of this would simply be, area is the base times the height. And again, we probably need some units there, so we'd say 4 inches by 2 inches, and that's going to equal 8 inches squared. Okay, and again, that's solved by doing what? Well, it's solved by decomposing the parallelogram. We take this rectangle right here, and we're going to take that, a triangle right there, and we're going to take it off, and we're going to insert it over here to now have the rectangle we're going to measure with a height and a base of 4 and 2. Okay, so now, sorry about that earlier, let's let you try one real quick. Okay, what is the area of this parallelogram? I'm going to sketch one here for you real quick, and then I'm going to have you solve that. And you can pause, or again, this might pause for you and allow you a chance to write it out. We're going to put a base here of 8 inches. We have our 90-degree angle. Our height is perpendicular to our base. And we're going to call this height right here 3 inches. Okay, so let's find out what is the area of that parallelogram. Okay, so hopefully you did some work there. So our area equals, again, base times the height, and in this case here our base was 8 inches and our height was 3 inches. 8 times 3 is 24, so our area is going to be 24 inches squared. Alright, so that's what we did in 6th grade as well. So we went from squares to working with parallelograms, and you might ask yourself, well, isn't that the same thing? Does it matter so much? Why did we even talk about parallelograms back in 6th grade? Why did that matter? Well, the reason that mattered, when we think about why parallelograms, was that gave us really a good intro to triangles. Okay? And that's why we talked about parallelograms, was in order to introduce and set up how the triangle ones work. Okay? If we take a triangle, and I'm just going to draw one right here. It doesn't have to be anything fancy. I'm just going to sketch one out. If I take a triangle like so, okay, and I copy that triangle, I'm going to copy it here with some patty paper. Alright, so there's my copied triangle, and I have two of them now. If I take that copy and I rotate it, I can rotate it so that, and let's do this here, I'm going to make sure you see how we rotate the right way. I'm going to make this edge blue and make this edge blue as well. And I want to rotate it so the blue edges are on top of each other, but I definitely want to rotate it completely. So I'm going to rotate it around and put the blue on the blue, and then what do I end up with? Well, once again I end up with a parallelogram, don't I? So again, I could copy this over if we chose to, right? If I wanted to kind of copy one of these over on the patty paper, now I have a parallelogram right here on the patty paper I can use. Okay, so now I have this shape right there. There's my parallelogram. So let's see if I can try to etch this into my paper so you guys can play with it as well. Let's see, I'm going to draw it there. Yep, it came through okay. So I have my match. Here we go. And of course we have our line right across there. So this is what I have. So I took my triangle, I made a copy of it, and I rotated it, and by rotating it and stacking it on top of each other, I then discovered that two triangles together actually form one parallelogram. So in doing that, right, what's interesting here of course is that this just means that the area of a triangle is what? Well, if it takes two of these to make the area of a parallelogram, then one triangle is going to be half of that. So let's think back to what's the formula for the area of the parallelogram. Well, the area of the parallelogram is going to be base times the height, which we've talked about. Now we know there's no height right here, so we would have to make sure we drew a line and figured out what the height would be. But the formula to find the area of that is base times the height. But if I just want to know what is the area of one of the triangles inside of the parallelogram, right? How many triangles is that? Well, it's one out of the two. It's one out of the two triangles, or half of this times the base times the height is the area of a triangle. So to find the area of a triangle, it helps to know the area of a parallelogram. Right? The area of a parallelogram is base times height. So the area of a triangle formula for that is 1/2 base times the height. So this is how you find the area of triangles, and this is how you find the area of parallelograms. Okay? Those are our differences right there. So using that formula then, area equals 1/2 base times height becomes the area formula for our triangle. So triangle area equals 1/2 of the base times the height. Alright, now let's do some practice with that. So what we're saying is if we took a triangle, and these are not going to be to scale, so don't worry about that so much, and I drew a height right here, and I had a height of 3 and a base of 6. To find the area of that triangle, I would take the area and set it equal to 1/2 of the base, which is 6, times the height, which is 3. And I would solve that. And again, I probably need some units here, so let's just say inches for now. So I'd have 1/2 times 6 inches times 3 inches. And you don't need the parentheses if you don't need them. That's okay. So I'm going to go ahead and multiply 6 times 3 first. So 6 times 3 is equal to 18 inches squared. Then I'm going to multiply 1/2 times 18, and that gives me 9 inches squared. So the area of this triangle with a height of 3 and a base of 6 is going to be 9 inches squared. Let's try another one real quick. Okay, this one is a right triangle, so it already has a right angle on it for us. Put that right angle right there. It has a height of 3 inches and a base of 5 inches. So again, using our formula, that area equals 1/2 of the base times the height, we would say the area is going to equal half of the base, which is 5, times the height, which is 3. We can multiply 5 and 3 together to get 15. So now I have 1/2 times 15. And at this point here, I have a half times 15, which is also 15 over 2. I can leave it there as an improper fraction or write it as a mixed number and make that 7.5. You don't need to turn it into a decimal. That's okay. If you chose to do a decimal, you could also say or 7.5. That works as well. And of course, it would still be inches squared to have some sort of unit with it as well, if these were inches. Okay, so we have what's called an acute triangle here, where all the angles are less than 90. We have a right triangle here, where we have one triangle angle, which is 90. And we could also do this for what we call an obtuse triangle as well. For an obtuse triangle, you end up having an angle that is greater than 90 degrees, like this one here, which gives you a really long side to work with, but it's okay. You're still going to have a base. I could have a base right here of 6 inches. Again, I'm just making that up. But what I need is a height. The height has to be what? Perpendicular to the base. So if I extend my baseline here, I could extend this out, and then from this vertex right here, I could draw a line, and we would say, oh, this is the height I'm looking for. The height would have to be, in this case, outside of the triangle. And it would usually be provided for you in a problem to solve, okay? So if we said the height was 2 inches, the base was 6 inches, now I'm back to solving the area, which is area equals 1/2 of the base times the height. All right, and 6 times 2 is 12, so I have 1/2 times 12 equals the area, and half of 12 is 6. So I would say it's 6 inches squared becomes the area for that one, that triangle there. So this is how we found the area of triangles. Let's go ahead and have you try one real quick. This will be our third question on this activity today. So I'm going to draw a triangle here for you. All right. And we're going to have a height right here. Our height is going to be 7 inches, and our base is going to be 12 inches. So go ahead and pause real quick, and why don't you work on that, and I'll come back and join you on it in just a second. Okay, so to find the answer here, we would say that the area equals 1/2 times the base times the height. And in our case, we keep the half. The base is equal to 12. The height is equal to 7. Okay. Now I can multiply 12 times 7 first, like I've been doing, but I'm going to go ahead and do this one first. Why? Because I can divide 12 by 2 because it's an even number pretty quickly with some mental math. Half of 12 is 6. So now I have 6 times 7, that's what's left. And then 6 times 7 is equal to 42. So these are inches, this would be 42 inches squared, becomes the area of that triangle right there. Okay, so this is all what we did in 6th grade. Again, 5th grade, we started with just basically understanding what area was about, working with some squares, some rectangles, and knowing that the formula for the area of a rectangle is base times height or length times width. We then went to 6th grade where we started talking about parallelograms. Again, showing that parallelogram is really talking about, that I'll actually say a rectangle is a special kind of parallelogram, and we can decompose that parallelogram into triangles to make this equal, make it look like it's back to a rectangle or square, and use our same formula. Knowing that about parallelograms allows us to then move into, we'll talk about triangles, that a triangle has the area of half of the parallelogram, which is where this half came from right there. And we worked that out as well. All right, so that's what we got from 5th and 6th grade. Now let's move into what we talked about in 7th grade. In 7th grade then, we started to expand our knowledge of area by now exploring circles. Exploring circles. And so you began with some new terms with circles. You might have talked about things called a radius. You might have talked about a diameter. You might have talked about something called pi, or maybe it looked like this. Okay. You might have talked about something called circumference. Okay. And these things all came up quite a bit as you were talking about things. And probably for the first time, we know in the area we talked about something being inches squared, but you probably talked more about what it means to square a number. Okay, so that's a number times a number. Okay, so let's take a look here what we're talking about. So if we had a circle, that's not a great one, I know. The distance from the center point to any edge of the circle is referred to as the radius. Okay, so that's the radius. The radius is the point going to the end of the circle. That's horrible. All right, the diameter would be the distance from one edge to the other edge of the circle, right? The diameter going through the middle point of that circle. So that's the diameter all the way across. And so one thing you probably remembered from your classes is that a radius is half of a diameter, right? So it would take two radiuses, to equal the length of the diameter. So 2r equals 1d. Pi is a number we use to talk about the measurement of a circle, and that can be written as a couple ways. It can be written as pi, or simply as a decimal, 3.14, or sometimes people use the fraction as 22 over 7. So depending on the problem you're working with, sometimes they ask you to keep it in terms of pi, which means you just leave it your answer with a pi in it. And sometimes they want you to work it out and find it to the nearest hundredth, which means tenths, hundredths, you stop there. We're going to do 3.14 and estimate there. Circumference then was that distance around the circle, right? So it's imagining, and you maybe have done this in class, imagine if you put a piece of string, and you took a piece of string and you wrapped it around the whole circle, how long would that string be? That is the circumference. Now, the formula for the circumference that you probably learned is that circumference equals pi times the diameter, right? And a pi value is here at 3.14, and the diameter would usually be given in the picture or example they would have. Or you could also say the circumference was equal to, because 2r is the same as a d, sometimes you learn that circumference equaled 2 times pi times r. These are the exact same formulas, just a different way of describing the radius or diameter. Diameter or 2 radius, it's the same thing. And we use this formula to find out the circumference of a circle. Okay? So, why talk about circumference of a circle? Well, because we're talking today about areas again, and we use the circumference to help us understand how does an area work. So let's take an example here of a circle. I'm going to take this circle here, and we're going to divide it into 6 sections. Let's pretend those are nicely drawn and it's perfectly even. Okay? Pretend with me. Alright, so we know that the circumference of the circle is circumference equals pi d. If I want to find out what the area is, one thing I can do again is I can decompose or deconstruct, right? Either way, this circle into individual shapes. Alright, so we're going to take these little pi shapes out, and we're going to kind of chop them up here and then organize them a different way. Okay, so here's one shape, here's 2, here's 3. Okay, so I got 3 blue ones. I'm going to make 3 pink ones. Now I'm going to organize this a little bit differently. Okay, so we're going to take the blue one, and take it out, put it right there. And then we're going to put a pink one beneath that, right here. Pink one. And then we'll do another blue one. And then we'll do another pink one. And another blue one. And our last pink one. Okay, so all we've done is we've just broken apart or decomposed or deconstructed the circle into 6 little equal pi pieces. Okay, now before we go much further, let's think about this. What do we call the distance from here to here? Call that the radius. So this length here, from here to here, right there, this whole length is a radius. It's an r. right? That's the length right there. Well, what is this length from here to here? Well, we know that the circumference is the distance around the circle, right? And we look at this side, all I have are the 3 pink ones, don't I? 1, 2, 3. There were a total of 6 pieces. So this length right here is half of the circumference, right? It's half the circumference. Well, what does that mean? Well, it's half, and the circumference is pi d. It's half of pi times d, or I could say it's half of 2 pi r. All right, let's go with that one for right now. Okay, so we have a radius here is how tall this parallelogram happens to be. All right, we're back to kind of a parallelogram looking shape here, but that's our height, is the radius. And then we have this length right here, which happens to be half of 2 pi r. Now, if we want to take the length times, or the base times the height again, let's take our base. Our base is 1/2 times 2 pi r, right? It's half of the circumference times the height, which is going to be r. Now again, I could say that's r there because it's a circle. The center point to the end is also going to be r as well. So this is going to be r, so don't think, well, that's crooked, it's not quite the height. If I go from the end point, a middle point of the circle, to the end of the edge of the circle, that is still going to be a height, and that's going to be an r. Okay, so our formula for the area is going to be half of the circumference times the radius, which actually is the height. So now let's take a look here what happens when I put this together. Well, a half times 2 is equal to 1, right? The 2's cancel out, the 1's cancel out, so this becomes just a giant 1. The pi stays a pi, and I have an r times an r, which becomes an r squared. So the area becomes simply pi, there's my pi, the 1, I don't need to write the 1, and then r squared becomes r squared. So the formula for a circle, for the area of a circle, is pi r squared. And that's where that comes from. It's just an extension of what we did with parallelograms, what we did before, but now we are decomposing that circle. We're putting it in smaller chunks to say that's the area for the formula for the area of a circle, just like that. Now let's try a couple of these here. If I had a circle, and I had a radius of 3, and maybe we'll say 3 inches, that's fine. To find the area, we would say it's going to be pi times the radius squared. Now back to that squaring. Squaring means to do what? It means to multiply the number by itself. So this is 3 times pi. Well, 3 times 3 is 9, and 9 times pi, we could either say, in terms of pi, we would leave it as 9 pi, and we would say inches squared. But if they want us to give a real number for that, then we could take 9, and we can multiply it by 3.14. And in doing that, when we do 9 times 3.14, we end up with 28.26 inches squared. That becomes the area of that circle right there. So you could either say it's 9 pi inches squared if you left it in terms of pi, or if you had to do more work with it, you would put an equivalent of pi, 3.14, in there, and then multiply it out to see what you come up with. Okay, those are both be acceptable. Sometimes in these circle kind of area problems, they give you the diameter. Now remember, the diameter is the distance from one edge to the other through the middle. Now our area for a circle, though, uses r. Don't forget, it uses an r squared, not a diameter. Okay, so that means you have to think, well, what is, so be thinking to yourself, what is the radius going to be? If the diameter is 10, the radius is going to be half of that. So 10, think about 10 times a half equals 5. So the radius is going to be 5. So the area for this one would be pi times the radius squared. 5 times 5 is 25. So 25 pi. And again, if I had to multiply that out, I could do 25 times 3.14. And when I do that, 25 times 3.14 gives me 78.5 2.5 inches squared. And that becomes our area for that circle right there. All right, so let's do a little one right here. I'm going to put number on number 4, I think it is. So here's number 4. Number 4 for you to try. All right, here's a circle. So we have a circle here. We're going to have a diameter of 20. So the whole length there is 20. Again, remember that's the diameter. So find the area of a circle with a diameter of 20. I'm going to pause here so you can work on that for just a second. We'll come back and check it in a moment. All right, hopefully you got a good answer here. Let's see what you have. Now remember, this is diameter. The diameter is 20, which means the radius is half that. The radius is going to be 10. So to find the area is going to be equal to pi times the radius squared. 10 squared is 100, so we have 100 pi. And if I put 100 times 3.14 times 3.14, we end up with 314. And I guess I should have a unit here. We could say inches squared. All right, so that's some basics with some circles. Now the next thing we do with the circles, though, is we've said, well, what if you only had part of a circle? So what if you only had part of a circle? And we might call that a semicircle like this. You only had part of a circle. Well, now what am I going to do? Okay. If I'm sitting here in half of a circle, and I know that the diameter is 12, well, let's see. The area of a circle is pi r squared. But now I'm talking about only having half of that circle, right? I'm only dealing with half of it. So the area of this shape is actually going to be equal to 1/2 times pi times r squared. What is the r in this case here? Well, I need to say the diameter is 12. The radius is half of that, so the radius would be 6. So we do 1/2 times pi times 6 squared. Well, half times pi times 6 squared is 36. Half of 36 is going to be equal to 18. So we have 18 pi. And again, if I did 18 times 3.14, I would find that I end up with an answer like 56.52. And again, I'm just saying it's inches for now, just to have something in place there. So 56.52 inches squared. So an area of half a circle, to find that, we use the formula for the area of a whole circle, and then we just make sure we multiply that by 1/2 to only get half of the area that we need. The same could be done if you had something like 1/4 of a circle. Like what if you had just 1/4 of a circle? Something like this. If I had 1/4 of a circle, oh no, what am I going to do? Well, let's see. If this happens to have a radius of 4.5, this would also be 4.5. So our question is 1/4 of the circle. What's the area there? Well, the area is going to be equal to 1/4 of pi times the radius squared. 4.5 squared, and then we multiply that out. Okay? So that's what we are going to be looking at there. So 4.5 squared is 4.5 times 4.5. Oops, 4.5 on my calculator. So I end up with 1/4 pi times 20.25. And I multiply that by 1/4. And now we have pi times 5.0625. And multiply that by 3.14. And we end up with 15.89. And I have 896. So if I had to round that to the nearest hundredth, which is usually what I would do, hundredth is right here, so I look next door. I'm going to round that up, so this goes up, and you have a 15.90, and again, probably inches squared if my unit was inches there. All right, so that becomes a common type of problem that you had in 7th grade as well. So let's have you give it a shot real quick. One for you to try. Here's number 5 for you. Why don't you find out what is the area of this half circle if it has a diameter of 10. So what is the area of that half a circle if it has a diameter of 10? Pause there, work that out, and then come back and check your answer. Okay, as we said before, if that's the diameter, we're not going to use diameter. If the diameter is 10, the radius is half that, we're going to use the radius of 5 in our solution. So area, or formula, area equals, well, in this case here, it's half of this, right? Half of pi times the radius 5 squared. Well, half of pi and 5 squared is 25, and then we're going to multiply that out. So 25 times pi times a half will give you 39.25. And again, if these were inches, we'd say inches squared becomes the area of half of a circle. Okay, so knowing that now we can figure out the area of a square, right? Length times width, or base times height. We can do a parallelogram, which is the same one, having a base and height. We can do a triangle, which is 1/2 of base times the height. And we can do circles, which is pi r squared. And we can even do half of a circle, which is 1/2 pi r squared, right? I mean, think about this. Half a circle is just like doing a triangle, right? A triangle is half of a parallelogram, and a semicircle is half of a full circle. So knowing that we can put all those things together, then we start to finally talk about composite shapes. And composite shapes means we're putting multiple shapes together. So for example, if I know the area of a rectangle, and it has a base of 3 and a height of 2, then the area is going to be equal to 2 times 3 is 6. If I have a triangle, right, and it has a height of 4 and a base of 3, I could find the area of that by doing 1/2 times 3 times 4, and we have 12 times a half equals 6. So the area of that triangle is 6. Okay? A composite shape says, well, what if I take the rectangle, the 2 by 3 rectangle, and I stack on top of it the 3 by 4 triangle, and I ask you for the area of the composite, the entire shape. Well, we know this has an area of 6, this has an area of 6. We'd add together and say combined, it has an area of 12 inches squared. And that's all that we have with a similar, with a composite shape there, is we're taking multiple shapes, finding the area of each, and combining them together. In a similar way, we can also take something out of a shape to find out what the area is going to be. So for example, maybe I have a square, okay, and I just want to look at half of that square, so I'm not even going to worry about that part for now, okay, pretend it doesn't exist. And inside that square I draw a semicircle right here, okay, and we have a shaded spot there and a shaded spot here, and I ask you, I'm going to erase this now, it's all going to go away, what is the area of the shaded portion there? And we know that this had a length of 6. Could we figure that out? Well, the answer is sure we could. Why can we do that? Well, it's a composite figure. What we have here is we have half of a circle, and if we have half a circle, the radius here is going to be 3 and 3, which means we have a height of 3. What I really have is I have two shapes, don't I? I have the rectangle shape, which is 6 by 3, which has a combined area of 18, and I have the semicircle here, which has a radius of 3, and that formula is 1/2 of pi times the radius squared. So we have 3 squared is 9, and then 9 times pi times half, right? So we can just do 9 times 3.14 equals that. So 9 times 3.14 times a half, so times 0.5 equals 14.13. Okay, So if I was asking for what the shaded value was, then I'm going to take the shaded space, the big amount, and I'm basically, it's like cutting that out. So I'm really thinking about what is 18 minus cutting out this half a circle, right? So we do 18 minus 14.13, and we end up with 3.87, and again it probably has some sort of units. Inches squared is what that would be. So the shaded region is going to be the rectangle minus the cutout portion right there. So just like we can combine shapes to put them together, we can also take things out to find out what's left by taking something out. Okay, let's have one here where you're going to give it a try here. So here's number 6 for you to do. And draw a shape here for you. I'm going to draw a line there. I'm going to go there. We're going to have a base of 3 of this triangle and a height of 2. Then we're going to have a little rectangle here attached to it. Okay, with a base of 4. And then we're going to have a semicircle right here, which has the same diameter as this height, which means you have to figure out what the radius is going to be. Okay, so for this question, go ahead and use this composite shape to find out what is the area of this composite shape. I'm going to pause here, let you work on that. Okay, so hopefully you got an answer here. Let's see what we have. First, I'm going to start with a triangle. The triangle is going to be 1/2 of the base times the height. 3 times 2 is 6, and half of 6 is 3. So I know the triangle has an area of 3. For the rectangle, I'm going to do base times height, 4 times 2, and so I have 8. All right, so I know I have those two together so far. Now I need to find out the area of the semicircle. It had a diameter of 2, but that means the radius was just 1. So the formula for the area of a circle, remember, is, in this case, half a circle, is half of pi times the radius, which is 1, squared. So we really have half of pi. Well, what is half of pi? Well, half of pi is 1/2 times 3.14, and that gets you 1.57. So the area of the composite figure is going to be 3 plus 8 plus 1.57, which means we combine that all together to give us 12.57, and it's going to be whatever units inches cubed. Okay? I'm going to let you try another one here. So here's number 7. Okay, I'm going to draw for you, in this case here, a square. Okay, this square has side lengths of 4. Alright, and if I look at the middle part here, right in the middle, I'm going to draw a triangle right here in the middle. Alright, if that's the middle, that's going to give this triangle a height of, it's going halfway, 2. And then I'm going to draw a semicircle right through there, which means it has a radius of what? 2. Okay, and we're going to color all this part in. This will be our shaded portion. This will be our shaded portion here. And the question is, what is the area of the shaded portion of that square? Okay, so that's our next little question there. I'll give you a moment to work on that, so pause yourself, give it a shot. We'll come back and check it in a second. Okay, so what we're looking at is we're going to have a square, right? And we're going to subtract from the square the area of the semicircle, and then we're going to subtract from the area of the triangle to find out that's going to be equal to the shaded portion. Okay, so the area of the square is 4 by 4, so 4 times 4 is 16. Got that there, no problem. The semicircle, well, the area of a circle, or half of a circle, is 1/2 times pi times the radius, which is 2, and 2 squared is 4. So 2 squared is 4, half of 4 is 2, so I have 2 times pi, I'm just write down, I'll write 2 pi for now, okay? Come back to that. And of a triangle, the base here is still going to be 4, and the height is going to be 2. So we have 1/2 times 4 times 2. 4 times 2 is 8. Half of 4 after 8 is 4. Okay, let's come back to our 2 pi. I'm going to do 2 times 3.14. 4. All right. So what do we have? We have 16 minus 6.28 minus another 4 is going to be the area of our shaded region. So we do 16 minus 6.28 gets me at 9.27, and subtract 4 more, and now we're at 5.72. And again, I'm just going to say inches for now. Inches squared is the area of that shaded region. Okay. Okay, we're doing well. Almost done here. So one final note. Final question, which you may be stuck on already, is how to find the area of a triangle if you don't know the height. Sometimes they don't give you the area of that triangle, okay? And then it's, or the height that you're looking for, and it becomes a little more complicated. I could have, for example, an isosceles triangle, okay? Or I have a height of 5, or sorry, a side of 5, a side of 5, and I have a base of 6. But because I don't have a right angle, okay, no right angle, I don't have an actual height here. So what I could do is I can draw this line, altitude line from the point up here, and make it perpendicular with this one here. Now this works because I have an isosceles triangle. It works out nicely. They don't all work like this, so be careful. Okay, so I can make a right angle there, and in doing that here, knowing that this becomes the midpoint of this line, poorly drawn triangle that it is, I have a base of 3 over here, a base of 3 over here, and I have these lines here that are 5. Okay, in one of the other videos you're going to look at, we're going to talk a little bit about the Pythagorean theorem. I cannot spell. Alright. So the Pythagorean theorem. Now Pythagorean theorem tells us that you can take a triangle. Let's take this triangle right here. And if it's a right triangle, the leg A squared times B squared is going to equal C squared. So in the case of our triangle here, we were given 2 pieces of information. We have this base right here, and we have this, what's called a hypotenuse right there. So we know that 3 squared plus, I don't know, we'll call that x squared equals, or we can call it b squared, just to keep it simple, b squared equals 5 squared. Now in this case, 3 squared is 9, plus b squared equals 25. I have to do a little bit of algebra, subtract 9 from both sides, so that b squared equals 16. To get the b by itself, I take the square root of both sides, and I'm thinking what number times itself can get you to 16. And sometimes you can tell what that is, sometimes you may not. 16 is one that I do know, but if I didn't, I could use my calculator and put 16 here. And if you turn your iPhone sideways, you can get this other feature here. And I just push the square root button. So the square root of 16 is 4. So b equals 4. So in the case of this triangle right here, I do actually have a height of 4. Knowing now that I have a height of 4, I could find the area of that whole triangle, which should be 1/2 of the base times the height. So half of 6 times 4, 6 times 4 is 24, that's going to be 12. So I can find the area of a triangle if I don't know the height, if I can form a right angle and then use the Pythagorean theorem to solve that and figure that out. Okay? Now, right now I'm using some nice numbers, okay? These are nice numbers. You don't always have nice numbers to work with, though. So here's another one with a nice number. Let's say I had a, well, that one actually I did, okay? These are nice numbers. So keep that in mind there. You're going to have to be able to do that to figure that out on your own from time to time. Okay, so let me give you one more problem to work with on your own, and then we'll call it a day. So find the area of this triangle. And this triangle is going to be an equilateral triangle, okay, meaning that every side is 12, 12, and 12. So I want you to go ahead and find the area of that triangle doing what we did up above. You're going to want to draw a little altitude line and make yourself a midpoint, and then use Pythagorean theorem to find out the height, and then come back and find the area. I'm going to press pause, give you a moment to work on it, then we'll come back and check it together in just a moment. Alright, here we go. So, first thing I'm going to do is draw a height right here and chop that up like that. So I have a right angle. If the base whole thing is 12, that means that this part right here is 6. And I can call this one up here B, or I can call it X, whatever you want to call it. So using the Pythagorean theorem, I can find out what that height is of that triangle because I have a right angle. So I know that 6 squared plus X squared is now equal to 12 squared. Okay, the line opposite of the right angle is always what it's equal to. That's called the hypotenuse. We'll look at that in another lesson. So 6 squared is 36 plus X squared equals 144. Because 12 times 12 is 144. I subtract 36 from both sides so that X squared equals 108. Now, again, this is not a nice number. Sometimes you get nice numbers, sometimes you don't. So if I put in 108 right here, I know that X is equal to the square root of 108. And maybe I just leave my answer like that sometimes. Sometimes, though, I need to use that number, like in this case, you're to find the area, so I can't leave it as 108. I need to get something close. So I'm going to go ahead and approximate that by pressing the square root button. And I have 10 point, back there. So 108, sorry, square root. I have 10.39. Now, nearest tenth says I can stop here because this number is less than 5, so I don't need to round it up. So I can say X is about 10.39. Now, our question, though, was to find the area of this whole thing. So X is just my height, so I'm not done yet. So now to find the area, I'm going to use this number. And the area of a triangle is 1/2 of the base, which is 12, times the height, which is now I know 10.39. So let's do this together. So half, I can put that as 0.5 times 12 equals 6. So this is 6 times 10.39. Multiply that by 10.39. And we have an area of 62.34. And again, probably inches squared is the idea. All right, so that's really it. Again, a lot of stuff here today, I know, but we were really going through a lot of 5th, 6th, 7th, and 8th grade work here to put everything together to help you understand how to solve some problems here on your summer homework. Hope that helps you out a little bit on a few of those problems. We'll see you in another video later on, and hopefully as soon as school starts, we'll see each other again. Bye. Have a great day.